Okay, we're now going to look at Mercator Sailing. When we solved plain sailing problems, we calculated the sides of the triangle in terms of nautical miles for delat and departure, rather than using minutes of arc directly. Now, the approximations in the method caused us to limit our distances to about 600 miles or less, and to accept that some error did occur. With the Mercator Sailing method, we read longitude as minutes of arc, so it's just simply the d long, and we read latitude in an equivalent angular form called meridional parts. So the difference in latitude, the d-lat, will now become the dmp, or the difference in these meridional parts. Hence, when we use units of distance, nautical miles, for our sides, we call the method plain sailing. And when we use the minutes of arc, the solution is called Mercator Sailing. So if we have a quick look at the two triangles, just to refresh, with plain sailing, this is our distance here, that's our course. This of course would be our d-lat. So if this is position A, position B, so we're going from A to B, that's departure, and of course tangent of the course, theta, is going to be departure over d-lat. Whereas with Mercator Sailing, tan theta is going to be the d long, so this is now d long, and it's over dmp. So the d-lat we're converting to meridional parts, and the departure, of course, we're reverting to minutes of arc, which is d long. So just to quickly talk about a Mercator chart, on the equator, if we looked at this box here, x, that would be the size of it in the actual area, and on our Mercator equivalent, that would be the same size. Now if we went to 60 degrees north and we had a box there, y, and that's the actual area, well, on the Mercator equivalent, the box is going to be quite a bit bigger, because Mercator charts, as the further north or the further south you go, they become distorted, in that, if we're squashing the globe and pressing it out. And if we were actually look at the map, somewhere like Greenland, you would think would be as big as the continent of Africa when you looked at the size on the Mercator chart, but in actual fact Africa's about, I don't know, 10, 14 times bigger than the Greenland. So you get this distortion when you use the Mercator charts. Now, a meridional part is defined as the length of 1 minute of longitude on the chart, and the meridional parts related to a latitude are the number of longitude units between the equator and the latitude. These will be measured along a meridian, and the difference of these parts to dmp is the arc of a meridian contained between the two parallels of latitude. So if we look at the Mercator Sailing formula, in the plain sailing triangle, the departure found is only approximate. It leads to errors in course and distance, whereas with our Mercator Sailing triangle, both the d long and dmp are accurate. Therefore we can calculate over long distances and we will get an accurate course and distance. So we're now able to find a course accurately using the formula tan course is d long over dmp. In the Mercator Sailing triangle, there's no distance side. This is because we're now using longitude units, which are of no practical use to the navigator when distances are required. We use the latitude scale, meridional parts, to obtain the distance in miles. So if we were to look at our triangle here, distance would be d-lat over cos course. So transposing the formula, cos course, we get distance is d-lat over cos course. So with Mercator Sailing, the two formulas that we use, tan course is d long over dmp, distance is d-lat over cos course. Now there are two common types of Mercator Sailing problem. Given two positions, we can calculate the course and distance from one to the other. Given a starting position and a course and distance, we can calculate a final position. So let's look at those two. So we're going from Cape Town to New York, and we've got both positions. We're going from 33.54 south, 18.25 east, to 40 degrees 40 north, 74 west. So we can always roughly work out what our course is going to be if we plot our position, if you like, on a compass rose, just very roughly. So we're at 33.54 south, 18 east. So say we're there at position A. We're going to end up at 40 degrees 40 north, so on the north side, 74 degrees west, so over here somewhere. So you can say Cape Town is here, New York's there. You can see we're going to go in that sort of distance. So we're going to go in a northwesterly direction. So when we're going from 33.54 south to 40 degrees 40 north, well, our difference in latitude, we'll need to add those because we're going from a southern hemisphere to a northern hemisphere. So our D-lat is going to be 74 degrees 34 minutes north, because we're going in a northerly direction. Longitude, similarly, we're going from an easterly longitude across to a westerly longitude. So again, we must add these two. So we're going from east to west, so we add and it becomes 92 degrees 25 minutes west, and we can convert those into minutes, 4474, 5545. So by doing the drawing, it indicates to us that we will need to add both these values to get our D-lat and D-long, and it gives us a rough idea of our course. Now, of course, you would then go into the Norris tables. Straight after the traverse part, you would look under meridional parts, you would look up your latitude along the top, degrees, and along down the bottom, minutes, and you would get your meridional parts. So we've done that, and we've got our MPs for both our latitudes. Now we do the same with those as we did with the D-lat. So the DMP is calculated the same way as the D-lat, and because we've added those two together to get the D-lat, we do the same with the meridional parts. So the DMP is 4811.1, two added together. Now we simply use the two formulas. Tan course is D long over DMP. Tan course D long over DMP gives us northwest, north 49 degrees 03.2 west. Now you can see the importance of naming it the right way, because we've got a course of 4903.2, and we need to know what the true course is. Well, it's north round to 49.303.2 degrees westerly. So in other words, we subtract that from 360. So 360 degrees minus the 49 degrees 03.2 will give us a course, true course of 310 degrees 56.8, and of course when we looked at our rough course, that's approximately what it is. To find the distance, it's simply D-lat over cos course, and that gives us a distance of 6,826.7 miles. So we've got the two positions initially, and we've now calculated we're going at a course of 310, 56.8 for 6,826.7 miles. Now what I'm going to do with the second example, I'm going to say, okay, that's our initial position, which is what we used first, our Cape Town position, and we're going to steam 311 degrees at 6827. Now the answer we had was 310 degrees 56.8 at 6826.7. So I'm going to use these values, but just round them up slightly. So we should get a pretty much the same answer, but just slightly out because we've rounded them up. So our course is 311 instead of 310 56.8, and 6827 distance instead of 6826.7. So the formulas. Well, distance is D-lat over cos course. Well, we know the distance and we know the course, so we can get the D-lat. And by multiplying 6827 by cos 311, we get 4479, and that equates to 74 degrees 39. So we write down 74.39. Now we know if that was our position there, we are going at 311 at 6827. So we know we're going in that direction, and we know we're going in a northwesterly direction. Therefore, our D-lat is bound to be north. So when we calculated it here, the D-lat 4479, we know it's a northerly direction. So we're going from a southerly latitude, and our D-lat's north, so we subtract one from the other because we're going across the equator, and we get a DR latitude of 40 degrees 45. And when we look at our answer for New York, it's 40 degrees 40, so we're 5 minutes out because we rounded up. Once we've got our two latitudes now, the initial latitude and the DR latitude, we can then look up the meridional parts for both, which we've done, and of course because we added these two together to get the D-lat, we do the same, we add the MPs up and we get the DMP of 4817. We know the formula d long is dmp times tan course, so we've got the dmp, we've got the course, we've been given that, and we multiply one by the other and get a d long of 92 degrees 21. Again, we're going from east 18 degrees, going in a westerly direction. So you would go from 18 degrees, if that's the meridional there, at 0 degrees, and that's west and that's east. We're going from 18 degrees east across. Now we're going a total of 92 degrees 21. So therefore we're going 18 degrees up to 0, then 73 degrees 56 westerly. So our longitude, dr long, is 73.56, and we can see originally it was 74 degrees for New York. So the answers we've got in the second part are very slightly different, but only because we rounded up our course and our distance. Had we used exactly those figures, we would have got exactly those there. So you can see it's a very accurate method of measuring a course and distance over a long distance. And we've done two problems there, one where we had both positions and we calculated our course and distance, and one where we had initial distance, initial position and course and distance, and calculated our final position. And it was just simply looking up in the tables the values with our latitudes, and by doing the little sketch it showed us which way we needed to apply to get the d lat and the d long. And that's how you would use the meridional parts, or to use the Mercator Sailing method to calculate courses and distances, etc.